Hello Thicketiers, I hope there are still some of you out there. Alistair Potts asked me to record this talk that I gave at the last Adam meeting. The main intention of this talk is to develop my understanding of this rather poorly understood biome. What I found encouraging after the last meeting is that several students came to me and they said, now they've got a vague idea about the vastness and the diversity of this biome. The main contents of this talk is basically to give you an overview of the major thicket types we have. There are a vast number of them, but I'll just stick to the absolute basic ones. I would like to talk a little bit about the ecosystem services of the thicket biome, because I think that is incredibly important, and especially in the Eastern Cape. I'll give you some idea about how I understand the resilience of the vegetation, the thicket vegetation, and I also would like to give you some indication of what I really think are important studies that are now still required. When we talk about the subtropical thicket, I think this is the picture that most people have in their minds. It's this dense vegetation with almost a closed canopy of all sorts of trees, and very often euphorbias emerging above the canopy. But it's only one of the great many variations. I think the first and most important point I would like to make about the subtropical thicket, which is still referred to as Albany thicket, erroneously by many people, is that it occurs in an environmental climatic region where the annual rainfall is about 50% summer rain, winter rain. Whenever this shifts beyond the 40–60% range, it changes, and at the margin from 50 to 40%, the subtropical thicket is no longer a closed canopy. It becomes broken up into a mosaic of vegetation types. This is one of the most important things I would like to explain. This band of about 50% summer-winter rainfall occurs quite widely along the southern coast, roughly from about the Breda River mouth in the west up to the Kei River in the east. But it also extends way inland in certain areas, right up to Grassland, for instance, and even to the basal parts of Cradock. Now, in the basic classification of the subtropical thicket, we've divided it up into 4 major units. All along the coast, there is a band of what we call Dune Thicket. And then slightly more inland, there's something we call Valley Thicket. More in the mountainous areas where there's higher rainfall, we have Mosaic Thicket. And then we have, beyond those mountain ranges, in the more arid inland areas, Arid Thicket. Now let's start off with the Dune Thicket. The first thing you will notice on this slide is that the rainfall range is very high. And that's an important thing to understand about the subtropical thicket. It's not about the rainfall range. It's the proportion of summer to winter rainfall. Look at the Dune Thicket rainfall. It goes from 350 to 950 per annum. As you can understand, because it's close, a narrow band all along the sea, there's not a very low minimum temperature. The average minimum temperature is about 7.7, and it doesn't get that very hot. It goes to 26.3. This example you're seeing here is close to wilderness and very typical, and almost the dominant tree in the Dune Thicket, which is mostly sandy soils, is the common milkwood, white milkwood, Soderloxon inermi. Now you may be surprised to know that we also called this Dune Thicket type. What you must understand is, as you move from the west, so in the Breda River, up to the Kei River area, the climatic regime changes. It remains mostly sandy soils, secondary dunes, maybe towards the east slightly more a loamy component in the soil, but the soils aren't major differences. It's actually a more climatic shift. So you can understand from the extreme west to the extreme east, there are some changes in the species composition. You can see in this slide there are even palm trees here. This slide was taken quite close to the Kei River mouth, which we still call Dune Thicket, because the successional processes that leads up to this vegetation type remains the same all the way along the coast. So the main point here is that, remember, there are several different dune thicket types as you go from the west to the east. Now, just inland from the dune strip, we move off from the dune sands onto more clay soils. Usually shales, sometimes there may be a bit of quartzite, there may be a bit of sandstone mixed in between, but in general more clay soils. And it's quite a warm climate. You can see the temperature range is not very wide. It's not very cold winters with an average of 3 degrees Celsius minimum, and it doesn't get that hot. The rainfall range is still quite high. It goes from 300 to 650 millimeters, but it's a real subtropical climate, and I think this is where the subtropical thicket is absolutely best developed. Now we named this variant valley thicket. It is typically has a very well developed crown of trees, a range of trees, and very often has this charismatic candelabra kind of euphorbias emerging above it. So this is one variant of subtropical thicket called valley thicket. But now, just as the dune thicket changed from the west to the east, there are many variants of valley thicket going from the west to the east. Now we're moving slightly more inland from the valleys adjacent to the sea, more to the mountainous areas. The basic mountainous areas that run all along the coastline. This is obviously where the rainfall gets a bit higher. You can see it goes now from 5 to 800 millimeters per annum. It's still not too cold in winter, about 4 degrees Celsius. It doesn't get that hot in summer, but the rainfall is higher and it's generally cooler. Now, these thicket types we call Mosaic Thicket, and the species present is quite different to the valley thicket. Instead of having dominant trees like Papia and Euclea, now suddenly something like Olea becomes dominant, and suddenly the charismatic candelabra trees are not that prominent. They're still present, but they're not that prominent. Now, once again, I have to repeat this, the Mosaic Thicket from the west to the east changes a lot. So there are several Mosaic Thicket types. Now let us hop over the coastal mountain range into the more inland dry areas that's in the rainfall shadow. You can see the rainfall is now much lower, 200 to 300 millimeters per year. It gets quite cold in winter and it gets very hot in summer. In general, now we've lost our tall, typical candelabra euphorbias. They've become much smaller plants, now generally known as Noordsveld. Very often, succulent species like a spekboom, Portulacaria afra, are quite abundant in this vegetation unit, but it varies quite a lot from the east to the west. I think the problem lies to convince most people that this is actually still fragmented subtropical thicket. What you have to understand with all the ice ages and the inter-ice ages there's been major retractions and moving back and retractions of subtropical thicket. The way I understand this is that what you have are clumps of subtropical thicket. If you actually go to a Gwarrieveld tree, Eucalyptus undulata like that, it's not a single tree, it's actually a mix of a whole lot of species. And even if you look at the species at the base, like some of the Grassland and so on, they're actually quite typical of arid thicket. The way I understand this, these are remnants of previous more summer rainfall areas. What has happened, the entire area used to be subtropical thicket, whatever, an arid type or even a valley type, who knows, eventually moving to an arid type and becoming more arid in summer, eventually just small clumps of subtropical thicket remaining. So I can't call this succulent karoo. The basic mosaic vegetation type you see here is typical succulent karoo vegetation. So what we have are dots and dots and dots and dots and dots of subtropical thicket in a basic matrix of succulent karoo. In strong contrast to the previous slide, where you've seen where the subtropical thicket actually merges with the Nama Karoo in the north, going north, getting colder. This is the extreme example going south, where the subtropical thicket actually merges with the Afro-montane forest. There's no ways you can call this Afro-montane forest if you look at the species present. See, there are still emerging euphorbias and a lot of other subtropical species. Just going slightly downslope from this, it actually becomes true Afro-montane forest. So the amazing thing about the subtropical thicket, it can go right into the arid cold areas in the north and forms a mosaic with vegetation types there, and it can come right down to the base where it's warm, where it's cool and moist, but it doesn't like it too cool. There are certain points in the landscape where several biomes clash together and a lot of species fight together. Fynbos, succulent karoo, subtropical thicket fight together, and there's a whole mix match and a mosaic of tiny little units, and it's hugely diverse in species. We call this Bondveld. Bondveld is not ubiquitous, it's not exactly the same. The one around Grahamstown and the one around Port Elizabeth, they're definitely not the same, but it's areas where vegetation types clashed and there's a great fighting and a huge diversity of species, and very often a large number of localized endemic species. So Bondveld is the ultimate where all these different circles intersect and it actually produces fantastic biodiversity. There are two environmental parameters that the subtropical thicket cannot deal with easily. On the inland side, it's cold environmental conditions like frost conditions. On the coastal side, you have another element, which is fire. Fires often spread from the mountains into the areas, from the upper plains into the subtropical thicket areas. If you look at this particular slide, you'll see a tiny portion of subtropical thicket with euphorbias emerging, which actually sits in just a tiny little spot which is protected from fire. What happens in this area where two major fire and non-fire biomes meet, you actually find tiny patches of subtropical thicket that can actually survive in a totally different vegetation type. Now let's move along to a much more clear example. You can clearly see this tiny patch of isolated subtropical thicket with Cussonia emerging and a whole range of typical subtropical thicket species sitting within a grassland. This slide was taken just halfway between Grahamstown and Port Elizabeth. What's happened here, for whatever reason, a tiny patch of subtropical thicket remained. And the environment around it is mostly grassland. So there's been fires ranging around it, and there's been many environmental factors that help this tiny patch of subtropical thicket to survive. This is obviously a clear example. We cannot call this just a grassland, because what do you do with patches of this subtropical thicket remaining within it? The only solution is we have to call it a grassland mosaic with thicket. Now beware when you move through the thicket biome. This may look like a grassland with tiny thicket mosaic patches left in it. But look carefully at the trees. They are umbrella shaped, and it's not a mix of species. It's only single species. In this particular slide, it is just papier surviving with opslag after good rain. So it's not an issue of a grassland with remaining thicket patches within it. It's human transformed example. The extent of transformation of thicket vegetation types, especially within the arid areas, is often hard to believe. If you look in the foreground, you see this red-flowered coral aloe, Aloe striata, and if you look in the background, you see those shades of pink. All of that actually is indicative of areas where the original Portulacaria afro speckboom was removed from the environment through grazing. So many of the areas that you will see have huge areas of transformation of original speckboom. The sad thing about especially the most of the arid thicket types is once you have transformed it, there is no natural process for it to reoccur and to re-establish. It's clearly that the thicket established during a period where conditions were much more conducive for species to re-establish. But currently, under the current environmental conditions, the species does not return. Here you see an example where for 50 years, an area was transformed through overgrazing and nothing has returned, unless there is human intervention to replant species like speckboom. This vegetation type will not re-establish naturally. Now we're getting to the point why it is absolutely important to retain the subtropical thicket, especially in the Eastern Cape. People living in the Eastern Cape will know it's one of those areas where it never rains or it pours. One of the vital, important functions of the subtropical thicket is to retain the vegetation along very often deeply incised river embankments. Can you imagine what other vegetation type can fulfill this function of surviving through years of drought and then suddenly be exposed to huge downpours without releasing all the soil of these embankments into the rivers? Just to reiterate from the previous slide, it's not only the river embankments that's often been devastated of subtropical thicket, but it's also the major upper catchment of this more inland area. A typical example where almost all the palatable species has been grazed out. Now just imagine when there's a downpour on this slope, where will the water go? It will just run off. The original solid subtropical thicket that was here would have held the water and infiltrated it into the groundwater system, which is a very important resource for human people to live from. Now what happens under such conditions is just all the water runs off, goes into the river system and causes all sorts of damage. And what happens? People suffer. As noted before, the subtropical thicket is very rich in all sorts of quite unique species. Many of these species have actually become very popular in the rest of the world. But the one thing about the subtropical thicket is it's one tiny part of the world that is absolutely unique, and it can be a unique environmental experience for ecotourists if people utilize the area properly. Let us look at the resilience of the thicket vegetation type. What you see here is an example of a landowner that decided that the solid valley thicket he had on his property is of no use to him. So he used a bulldozer to open the area to increase C4 grasses that can be grazed by cattle or whatever else not. You can see it came at quite a cost at the bulldozer because the thicket is quite resilient. But what happens now, you would expect that the thicket would gradually and easily re-emerge within these open areas, but it does not happen. So something about the valley and the arid thicket is quite odd. It does not return in areas that's been opened, even in small areas like this. Now let us zoom out and have a satellite image of the Eastern Cape area. What you're seeing is the Addo National Park. The upper road is the one that goes to Patterson, and the bottom road going up is the one going from Port Elizabeth to Sierberg. Effect is, this is the Addo National Park. I'm pretty sure that you can see this does not look very healthy. If I was a pathologist, I would have said this is a patient dying of serious cancer of various degree. There are all sorts of developments on the left, and there are all sorts of developments on the right. But you can see what there should have been in terms of a functional organism is no longer there and is highly fragmented. Now this raises the question of exactly to what extent can we fragment the subtropical thicket where it still sustains the main important role it plays to support the ecological systems that support the environment. We urgently need to develop an understanding what the sustainable utilization levels of the different thicket types are. Here you see an example with an Addo Park. It must be clear to you that in the foreground what should have been subtropical thicket has been altered to absolute basic grassland. Even look at the background, there is a cutting in the background where there's been an opening and no thicket reappeared. surely this is not a sustainable level of utilization of the environment. But for we as scientists, it is important to get a grip on what is sustainable. Just in complete contrast to the previous slide, here you see subtropical thicket that is solidly overgrown. And if you actually manage to get into all that spekboom veld and stuff at the bottom, you find pretty few species. This is clearly not an alternative. So somewhere there must be a balance between grazing and not grazing. I'm a firm supporter of the intermediate disturbance regime. The previous slide showed extreme on the other side. This shows the slide on the extreme other side where there's no disturbance. There must be some balance in the disturbance regime for subtropical thicket and all its variants. This is just another slide to reiterate the previous one. This is the little nature reserve just outside East London, where there's been no disturbance for a very long time to protect the Umtiza tree. What you could see here is that the entire area became totally overgrown by trees because there's been absolute no disturbance, and the original cycads that occurred in the area are now becoming outshaded by the trees. So we clearly need some intermediate disturbance regime. Just sometimes you run across examples of where there's perfect balance between land use management and protection of species. This slide was taken just out of Fort Beaufort, and it's in that area where you have the interbalance between fire and thicket. The landowner did not interfere at all. You can maybe see in the center of the slide a little group of a herd of cattle. And it's just a perfect example of where land management and environmental needs perfectly met each other. Just to reiterate this point of finding the absolute fine balance, this slide was taken within the Bondveld of Addo Elephant Park, where it used to be very finely managed, and you can actually see very happy animals and great Thimedo growing. It's finding that very fine balance, but we still need a lot of more information to understand, to get to the point of a fine balance. So how do we get to the point of re-establishing an example of subtropical thicket, valley subtropical thicket, that naturally restored along the road to the Fontaine, just north of Uitenhage, where there's a whole range of species. The grasses at the base, they're eventually giving way to all sorts of trees and shrubs and whatever, and lianas emerging. How do we achieve this in open areas? It's a major open scientific question. I hope that this introduction to the subtropical thicket will get you a little bit enthusiastic and help you to understand it, and also see all the different problems and things that we still need to understand. I really hope that there will be 1,000 students coming to study the subtropical thicket.